Hi class, today we're looking at Chapter 9, Lesson 4, Compound Events. So you can find the probability of more than one event, such as winning a game twice. A compound event consists of two or more events. Two events are independent events if the occurrence of one event does not affect the probability of the occurrence of the other. Let's write that down. So a compound event, two or more events, an independent event, one event that does not affect the other. So let's look at the probability of an independent event. So if A and B are independent events, then the probability of A, then B, equals A times B. So let's put that into perspective with an example. You and a friend play a game twice. What is the probability that you win both games? So the probability is you have a 1 in 2 chance. You're either going to win or you're going to lose. So if our probability is 1/2 for A and 1/2 for B, then you just multiply them together. So you have 1/4 chance, 1 out of 4 chances that you're going to win both games. But then let's look at a dependent event. So in a dependent event, is the occurrence of one event affects the probability of the second. Write that down. So in a dependent event, the occurrence of one event affects the probability of the second event. So in that case, if the event B depends on the event A, then the probability of A then B equals the probability of A times the probability of B after A. So let's use an example. So you select a card at random from these below. The card has the letter M. Without replacing the M card, you select a second card. Find the probability that you select a card with the letter A after you select M. So there are 10 cards remaining after you select M. So the probability of selecting one card with the letter M. So let's see here. There are 2 M's out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So selecting an M the first time is a 1 in 10 or a 1 in 11 chance. 2 in 11 chance. After that, if we do not replace the M we selected, now we have 1 chance of selecting a letter A. So there's 2 A's out of 10. And now we multiply these together. So then we get 4 out of 110. So the probability of selecting M and then A is a 4 in 10 chance. But I just read the question a little bit more closely, and it says the probability of selecting the card with the letter A after you select M. So really that's a 2 in 10 chance. We can reduce that, divide the top and the bottom by 2, and that gives us 1/5. So there's a 1 in 5 chance that you will select an A after you select an M. Okay, so you try this one. You select a card from a bucket that contains 26 letters. It's 26 cards lettered A to Z without looking. Without replacing the first card, you select a second one. Find the probability of choosing C and then M. So this is where you're going to multiply them all together to get it at this level. Press pause, see if you can figure that out. Come back to me when you're done. So you should have come up with 1 out of 650 chance that you will get C and then M. So right, I just took 1 out of the 26 letters, and then I didn't replace it, so then there were only 25 letters left, and I wanted one particular card. That was my chance, 1 out of 25, and then multiply those together. So here is another 2 that I want you to try on your own. You select at random. Oh, you select at random without replaying the T card. What did I do? You select, let's see here, sorry about that. You select a T card. At random. Oh, I guess I didn't have to. Without replacing the T card, you select a second. Find the probability of S. Whenever you see it with just a P and then the something in parentheses, the P stands for probability. Okay? And then suppose 2 sets of 26 cards lettered A to Z are put in a bucket. Find P, the probability of J, then J again. Okay, press pause, see what you come up with. Come back to me when you're done. Okay, so you should have got 1 out of 10 chances for the first one, and 1 out of 1,326 for the second one. The first one I didn't really show my work, right? You selected a T, so there's only 10 cards left and there's only one S, so 1 out of 10. And then 26, there's 2 sets, so 26 times 2 means there's 52 cards. I select 1J. When there's 2 in there, now there's only 1 in there because I don't replace it, and there's only 51 cards. Okay, so let's check out this. There's more than one way to do this. So you toss a coin 3 times. What's the probability of getting heads? Brianna, she tosses a coin in an independent event. The probability of getting heads for 1 coin toss is 1/2. I can multiply the probability of the 3 coin tosses. So she just does 1/2 times 1/2 times 1/2, and that equals 1/8. So the probability of 3 heads is 1/8. Chris says he can make a tree diagram for the coin tosses. A favorable outcome is one with 3 heads. The tree diagram shows one favorable outcome, so here it is, of 8 possible outcomes. The probability of 3 heads is 1/8. So he made this tree chart and then looks at the outcomes to be able to identify 1 out of 8. So they're getting the same answer, but there's 2 different ways to do it. So you decide which you like to do more. If you like to draw charts out, then you might want to use Chris's method. If you don't mind multiplying, then Brianna's method might be easier for you. Tonight's homework is page 329, numbers 3 through 21 odd. Happy homeworking!